In this video, I will be explaining how to solve circuit-based problems. I will cover all the possible questions with the help of the following problem. Here you have a cell 14 volt and internal resistance 1 ohm. It is connected to an ammeter, 3 resistors. The ammeter has a resistance of 0.8 ohms, which is connected to a resistor of 4 ohms and 2 parallel resistor which has a resistance of 3 ohms and 2 ohms. Let's start with finding the reading of the ammeter. Now when you calculate the reading of the ammeter, it is basically the current through the circuit. So your first aim in a circuit based problem will be to find the current through the circuit. So the only formula which we will use throughout the problem will be Ohm's law, which is equal to V is equal to IR. So since we have to find I is equal to V by R, where V is equal to EMF and R will be the total effective resistance. So in order to find the effective resistance of a parallel set of resistors, we'll use the formula 1 by Rp is equal to 1 by R1 plus 1 by R2, which is equal to 1 by 3 plus 1 by 2, take LCM, 2 plus 3, 5 by 6. So Rp will become 6 by 5, which is equal to 1.2 ohms. Now the remaining is connected in series, as you can see here, 4 ohms, 0.8 and then 1 ohm. So total effective resistance will be equal to 1.2 plus 4 plus 0.8 plus 1 ohm, which is equal to 5, 6, 7 ohms. So now we can calculate the current, which is equal to EMF by total resistance, and EMF is 14 and total resistance is 7, which is equal to 2 ampere. So this will be the current through the circuit. Next we have to find voltage drop and terminal voltage. Voltage drop is the potential difference within the battery and terminal voltage is the potential difference across the terminal of the cell. So now in order to calculate voltage drop, which we represent with small letter V, is equal to I into R. Small letter r is internal resistance. So internal resistance is a resistance within the battery. We have already calculated I is equal to 2 ampere. So using that, what we can do, I will be 2 and R within the internal resistance within the battery is 1. So which is equal to 2 volt. Next we can calculate terminal voltage. Terminal voltage can be calculated using the formula EMF minus voltage drop. This is voltage drop. So EMF is 14 volt minus voltage drop is 2, which is equal to 12 volt. Now we need to calculate the voltage across each components. In order to understand how voltage works, I will redraw the circuit. You can see I'll start from the point A. We'll move to the ammeter. Ammeter is connected to the 4 ohm resistor, which is connected to the parallel resistors, and finally connected to the battery. And go back to the point A. Okay. When components are connected in series, current remain same, whereas voltage gets divided. So we have already calculated the current. Current is equal to I is equal to 2 ampere. And voltage gets divided. So in this case, what happens is like we have voltage in the ammeter, voltage in the 4 ohm resistor, voltage for the parallel resistors. The voltage across parallel resistors are same, and finally the voltage at the battery. So the formula here we are going to use is V is equal to IR, where V is the voltage of the component, I is the current through the circuit, and R is the resistance of the component. So let's calculate. So VA is equal to I into R, where in ammeter the current is 2 and the resistance is 0.8. So if you multiply, 1.6 volt. For a parallel, I into R, I is equal to 2, and R is the effective resistance between the parallel resistors, which is equal to 1.2. You'll get it as 2.4 volt. Difference in the battery has already been calculated, which is the voltage drop, which is equal to 2 volt. So for verification purpose, if you end up adding voltage at the ammeter, voltage at the 4 ohm resistor, voltage at the parallel resistors, and voltage at the battery, will sum up to 14 volt, which is equal to the EMF. So keep in mind, when components are connected in series, the current remains same, voltage gets divided. Next, we have to find the current through each components. As I've already explained, when components are connected in series, the current remains same. As we have already calculated, I is equal to 2 ampere. Current through the battery will be 2 ampere. Current through the ammeter will be 2 ampere. And current through the resistor, 4 ohm resistors, will be 2 ampere, since all of them are connected in series. The part where you have to remember is when components are connected in parallel. So we have only one pair of parallel resistors, so 3 ohms and 2 ohms. So when components are connected in parallel, keep a note, voltage remains same, current gets divided. So if you look at it, if I is the current, then the current flowing through it will separate into I1 and I2. So the formula here, what we're going to use is I is equal to V by R, where I is the current through the component, V is the potential difference of the parallel component, and R is the resistor of the component. As we have already calculated from the previous part, the potential difference of the parallel component is V is equal to 2.4 volt. So using that, first we can find I1. I1 is the current through the 3 ohm resistor, which is equal to V by R. The potential difference across the parallel resistor is 2.4 and the resistance is 3, which is equal to 0.8 ampere. I2 is the current through the 2 ohm resistor. So for again formula, V by R is equal to voltage is 2.4 and resistance is 2, so which is equal to 1.2. So as you can see over here, if you add these two, you will get 2 ampere.